charm, but it's now a new day. I let the headphone set charge all night, so that shouldn't be an issue again if it kept dying on me yesterday. Okay, so we had just talked about in the last video, we got through looking at the inverse tangent function compared to the original parent tangent function and looked at how the domain and range flip. And this one was different than sine and cosine because this domain is all real numbers now. So any input will have an output. Okay. So it talks about, you should see the tangent's domain is restricted so that the it's parentheses, not brackets, so you don't include those. We talked about that in the last video with those being asymptotes. They're not included. We know that tangent is sine divided by cosine. Okay, so anywhere that cosine is 0, remember tangent's going to be undefined. Around the unit circle, that's at pi halves and at 3 pi halves or at negative pi halves. So that's why it's undefined. That's where those asymptotes are coming from, and that's why it's parentheses here instead of brackets. It says you may also notice if something that's different. Oh, the domain's not restricted, so it's all real numbers. We've got that. All right, so the quadrants that your inverse tangent functions are going to come from are going to be from quadrants 1 and 4, just like inverse sine. Okay, except this time, you draw this, these are out. So you're either going to have your positive angles coming from quadrant 1. Okay, so if the value is positive, then you know your answer must be coming from quadrant 1 because that's where tangent's positive. And if the value is negative, then your angle must be coming from quadrant 4 because this is where tangent is negative. And here, the negative and the positive pi halves are not included. Okay, put a circle between those, not including them. All right, so in these examples 6 and 7, we've got arctan, remember that's the same as inverse tan, of 0. So this is tangent's value 0. So if you need to sketch a picture, sketch a picture. We know inverse tangent will not be here. It's going to be in one of these. Now, 0 it's in between them. Here is where tangent is 0 because the ordered pair is 1, 0. You'll remember that this is cosine, this is sine, and tangent is sine divided by cosine. So 0 divided by 1, tangent is 0 here. Okay, so this is at 0 radians or 0 degrees is where the value will also be 0. Now this one is written as inverse tangent of -1. So again, if you need to, draw yourself a picture. You don't have to. Once you start getting the hang of this, you won't have to draw pictures anymore, but I know my solutions are not coming from over here for inverse tangent. Now, this value is negative, which immediately tells me I'm coming from this, my answer is going to be in this quadrant because tangent's positive in quadrant 1. Because remember, all students take calculus. All of them are positive here. Only cosine's positive here, so tangent must be negative here. So since it's negative, that right there tells me that our angle. So then I just have to remember those special angles, 45, 60 degree reference angles, which one has a tangent value of 1, and that's at 45 degrees, okay? Or in radians, that's your pi fourths, but we're in this quadrant, so this angle is negative. So this is at negative pi fourths, or negative 45 degrees if you were answering in degrees. All right. All right, so we've gotten through reviewing. Um, y'all, a lot of this may have looked familiar. I don't know how much you remembered from before the break, but this is everything that kind of these graphics up here, that Desmos activity that you did before Thanksgiving, that Thursday before Thanksgiving, went through trying to explain, okay, or let you see, kind of discover that what the inverse functions looked like and why they were restricted. Okay, so this is a nice little recap. It has all three of them side by side: inverse sine, inverse cosine, inverse tangent. Okay, and the domain and range of each of those, and a visual for the graphic of those so that you can see them. Okay, so you can refer back to that as well. Now, compositions of inverse trig functions. So remember, and I don't know if it was actually 1.7, these are notes from a previous year, and I know we've reordered stuff, but back earlier, sometime in Unit 1, we talked about composition functions, f of x, or and g of x. You had two different functions, and then you would do f of g of x or g of f of x, where you input one function into another. Okay, and then we talked about inverses with functions, and we said if you input an inverse into a function, okay, if these two functions are inverses of each other, when you input them into each other, it doesn't matter which one's the outside or inside function, either way, everything simplifies down to just x. That's the same thing with trig functions. That rule still applies because they are still functions. So if you have a composition of a trig function and its inverse, it's like those operations are just going to cancel each other out. Okay. Now, this one, it says, however, since the domains of trig functions are restricted, uh, it's not going to necessarily be exactly the same. It won't. Sometimes you will have like a no solution or something. Um, but the concept is the same, and that's what this key concept box is going to show us here. But before I scroll all the way down to that, let's go ahead and fill in these blanks. So this says sine is defined for all values of x, but the domain of inverse sine is only -1 to 1. Okay, so there will be different restrictions applied for sine of inverse sine of x versus inverse sine of sine of x. So up here in the previous functions, it didn't matter which way we applied, which one was inside or outside, which one was the input, or which one was the outer function. Okay, but with the trig functions, because the domain is different, it will be slightly different. Okay, there's going to be different restrictions. Okay, so that's what this key concept box here is telling us. I'm going to just put a little note to help you understand here. Versus outer function. Okay. All right. So what this says, if the inverse function is the input, that's on the left, this list. If the inverse, and I say the input, the inner function is a better way of saying that. Okay. Versus if the inverse function is the outer function. That's this list on the right. Okay, so I'm just going to pick 3 colors here. I'll use yellow. Okay, so for it will simplify down to just x as long as the x that you're inputting, as long as this value is between